Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the 7th video in my series on threads. So far in this series, we've been covering the fundamental skills for creating and running threads. We've talked about the various thread start delegates, how to pass data in, how to make our data thread safe and get data back out. We've talked about canceling a running thread and also safely handling thread exceptions. Today, I want to introduce you to a really interesting C# helper class called the BackgroundWorker. Now, BackgroundWorker is part of the System.ComponentModel namespace. And that is an older .NET namespace that really had to do with building WinForms apps. For example, it contains things like a binding list, which allows you to make data-bound controls. So this is all about Windows executable development, WinForms and desktop apps. However, even if you are not developing a Windows Forms application, the BackgroundWorker is really cool to know about because it does all of the things we've been doing manually, such as handling exceptions and implementing cancellation. Well, it supports those activities very naturally and simply through a lovely event-based model. So if I were to be building an app that required one or more background threads, I might seriously consider just implementing it with the BackgroundWorker. All right, so here we are in Visual Studio, and I've created a class called BackgroundWorker Demo with a method for running our BackgroundWorker. I've also created a little data class called WorkerResult, so the worker can communicate what happened, and it has a status of completed, failed, or canceled, and a little message we can use. So let's just jump in and create a BackgroundWorker. So we instantiate the new worker, and you'll notice it doesn't take a delegate in the constructor. Instead, we handle an event called doWork. So there's our doWork event handler. Now the BackgroundWorker has another event that we want to handle called worker.runWorkerCompleted. You'll see how this works in just a moment. So first off, let's implement our doWork event handler. So we can say fancy logger.log, enter doWork, and let's do some work. So maybe we'll use our simulated jobs, do something CPU intensive for a couple of seconds, and then fancy logger.log, exit doWork. So now we've got our basic worker going. And we can also implement our basic run worker completed method by simply saying fancy logger.log worker completed. And the last thing we need to do is actually run the worker. So we'll say worker.runWorkerAsync. And I think I'll put a few messages here just to make the point. We'll say launching background worker. And when we're done, we can say background worker launched. One small thing I want to point out. You notice how this method is called runWorkAsync. And you might think, oh, that's something I can await. That's like an async await method. Well, it's not. If you look at it, it returns void. It doesn't return a task. So this actually predates the whole async await thing in C#. It's just telling you that it's going to run on a worker thread, but it is not awaitable like a true async method, or a method that's declared as async. I mean, it is asynchronous, just in a different way. So I think that's about all we need to run our worker. Let's see if this builds. It does. And let's see if we can run it. I'll press enter to start. And there we go. So on the main thread, thread 1, we can see it was launching the background worker, and then it launched it, and right away we get the message, background worker launched. So what this tells us is our main thread is free to do other work. This really is parallel processing. Then on thread 5, we entered the do work method. We did our CPU intensive task for a little bit, and then we exited it. And then we got this cool worker completed event. And what's interesting is it shows up on thread 9. It doesn't necessarily show up on thread 5 or even thread 1. So a little bit like tasks, you have to be careful here because after you await this, it's going to come back to you and you're not always guaranteed which thread it's going to be on. So there's our basic background worker. Let's improve it a little bit. The first thing I want to do is we'll pass a little data in. And just like thread.start, well, run worker async takes an object. So you can pass any arbitrary data to it. And that data shows up here in your do work event args as follows. So we can say enter do work with data e.argument. So e.argument is the object that you passed here. So that should be the number 42. Of course, you can use a data class, pass whatever you want in. The other thing that we want to be able to do is support a result. So if you look at do work event args, you'll see that it has a property called e.result, which is also an object. So let's use our worker result for this. So we'll say result equals new worker result, and we can say status equals worker status dot completed, and the message equals nice job. So now when our worker exits, this data is going to be available, and it's available to this event handler through the run worker completed event args, which also has a property called result. Now it's typed as an object, so we have to cast it. So we'll say worker result equals the result in our argument cast as a worker. And now we can say the worker completed with result dot status and result dot message. So let's watch all of this now. Let's build it. Great. And run. Press enter to start. So the first thing you'll see is that we began do work with data 42. So we passed it in and the worker had access to it. And the next thing you'll see is that the worker completed event had access to the results. Completed, nice job. So now we can leverage this and use it for a few other important things. The next thing I want to show you is exception handling. And exception handling in a background worker is just like exception handling with a thread. You always want to have an outermost try catch right here in your worker method. I do believe the background worker actually will keep an unhandled exception from crashing your application, so that's good, but you still don't want to have unhandled exceptions. So what do? Well, instead of returning worker status of success, why don't we simply set result to worker status failed? And the message could be our exception message. That'll work. Now, to simulate this, we have to throw an exception. So let's throw new exception. Uh-oh, that was very bad. And now if we build this and run it, we should see nice, clean exception handling. There's our app. Press enter. And boom. Okay, no exception, nothing halted. instead, the completed event handler simply got the message. That failed. Why? Uh-oh, that was very bad. So that is a simple and clean way to communicate, or to trap exceptions and communicate the result to the other threads that care. Again, looks just like we did with threads. It's just nicely handled because there's this result object that lets us pass the data around. So the last thing I want to do is show you a cancelable background worker. So let's do that this way. I'm actually going to take out the body of the method there. And to make this thing cancelable, we're going to say int I equals 1. And we can do while true. And fancy-logger.log loop I++. And thread.sleep for a second. So now we're going to, in a moment, we'll check for cancellation here in just a minute. So as you can see, our worker now is simply going to loop and loop and loop and loop until it gets canceled. To make a background worker cancelable, the first thing we have to do is say worker supports cancellation is true. That sort of turns on the cooperative cancellation pattern. And we have to signal it to cancel. So let's do this the same way we did with threads, where we can say console.writeLine, press enter to cancel, and then console.readLine. So once we press enter, that means we're ready to cancel. How do we signal cancellation? Worker.cancel async. And we can log this. So let's say fancy-logger.log requesting cancellation, and then we'll request it. So how does the worker know that cancellation has been requested? And the key to that is that this object, the sender, it's actually a reference to the background worker itself. So we can now do this. Background worker equals cast the sender as a background worker. And then here we can check and say if worker dot cancellation pending. So that's our cancellation helper flag, right, in the cooperative cancellation pattern. So that will get set to true if it's time to cancel. So now we can just say fancy-logger.log cancel request received. And we want to return a result. We can say e.result is worker status dot canceled, and our message can be, okay, I stopped. And then, of course, we have to break out of our infinite loop. So again, it'll keep polling until we get the flag that a cancellation is pending. Then we can log that we received that message, set a special result, and break out of here. I think that should do it. Let's build this. Make sure everything compiles. Looks pretty good. Let's go ahead and run it. All right, let's press enter to start. Loop. Oh, that is ugly. I++. Sorry, this should have a $sign. So let's try that. There we go. Loop 1, 2, 3, 4. Are we ready to cancel? I am. How about that? Now you can see we hit enter, and immediately the main thread said, okay, I'm requesting cancellation, and then it set cancel, async. Then the worker itself says, hey, I got a cancel request, and it breaks out of that loop. And then the worker completed gets the result. It was canceled with the message. So there you go. That's pretty much a fully implemented background worker. We passed data in, we got data back out, we handled exceptions, we made it cancelable. Everything we did with threads now, just a little bit more simple and elegant with a background worker. So now you've got the option to use that. I really like this class, and I hope you find a way to use it. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.